everyone. Today we are going to discuss about how OSI or TCP/IP reference model works in real time. The basic purpose or main motive of OSI model is which allows different network hardware and software devices to communicate. The purpose of OSI model is to which helps in communication between different devices irrespective of hardware, software or operating system. It helps in communication between each other devices with the help of these layers. This is the reference model which is followed by the every vendor, every device. Okay, so let us see the different layers in OSI and TCP/IP reference model. So OSI reference model follows the 7 layer reference model, and TCP/IP follows 4 layer reference model. The functionality between OSI and OSI reference model and TCP/IP will never change. The both works on same concept, just representation of layers will be different. As you can see, in OSI reference model we have 7 layers and TCP/IP have only 4 layers, because in TCP/IP application presentation session layer combined together called as application layer, and transport layer will remain transport and network as a network also, and data link and physical will combine together called as network interface. So OSI reference model is having 7 layer and TCP having 4 layer, but the functionality remains same. Let us see the functions of each layer, like how exactly the each layer works. So the application layer, which is the top layer of OSI model, which provides interface between user and machine. The purpose of application layer is it provides an interface between a normal user, a human to human and machine system. It provides an interface to interact each other. Let us take an example of Chrome, which act as which provides an application layer. Okay, which provides an application layer to interact with the other website. We can search any website by using Chrome. So Chrome provides an application layer interface which helps in interacting the user with the machine. So the different types of protocols which are used in the application layer are HTTP, HTTPS. Basically, HTTPS used to secure web browsing, and HTTP is not secure because SSH certificate is not added in the HTTP. And SMTP is for use for mail, and DNS is for domain name. So there are different types of protocols which are used in the application layer. Let us see the presentation layer. Presentation layer perform 3 processes are translation, encryption and decryption, and compression and decompression. So let us understand what exactly the translation means. When we enter something on the Chrome browser, we enter in a human readable format text, which is non-understandable by the system. So to a system will understand only binary digits, binary understanding. So the data what are the we entered in form of text, which will be translated to binary, is called translation, which will be translated by using protocol ASCII. The entire data what we have entered on Chrome browser, it will be translated so that the machine can understand the language. Okay, and encryption decryption is used to provide the security to the data. Let us take an example. We are transferring a data from one device to another device, so the data must have to be encrypted, because uh, to provide security from the hacker, so that anyone else cannot be access that data. If someone catch that data also, they should not have the ability to read that or get the information what the data is having. So encryption is providing security to the data by using algorithms like RSAES, which provides, by using particular algorithms, the data is converted into the some non-human readable format and cannot be retrieved back to the human readable format without having key. Without having key, the data is cannot be decrypted. So encryption is provided in the presentation layer to provide the security to the data. And compression is used to reduce the size of the data at the one end, and decryption is used to uh, decrypt the data at the another end. Okay, when translation is happening, the if a text is having, if we are having data in form of text, then it will be converted into binary using protocol ASCII. If we are using the data like image, and it will be converted into JPEG format, machine readable format, by using the protocol JPEG. And simply similarly for videos, we are using, system uses the MP4 protocol. Okay, so basically presentation layer performs the three main functions: translation, encryption, and encryption or decryption, and compression and decompression in presentation layer. Session layer helps in establishing session between client and server. It comes in picture when a user is establishing connection between a server. So it helps in establishing this session. So it is the one which is responsible for establishing this connection, session, and it is responsible for maintaining that, and also to close the session. The protocols which are used in the session layer are SQL, SIP. There are different. So let us see the transportation layer. The function of transportation layer is to add source and destination port. Okay, so till here, from application layer to session layer, it not involved any header. Okay, and it also not require any data to do this process. Okay, so when it comes to transport layer, in transport layer, the data what get from what you get from the application layer, presentation layer, and session layer, it will be added header. Header is the where in header it will be added the source and destination port. Source and destination ports, which are very important to use the particular services. Like let us take an example of DNS service, which is uses the port number 53, and HTTPS uses the port number 443. So basically, port is a door which allows any device to access the service from server. Okay, so there are three types of port numbers: random, well-known, and reserved. Where random in source port, random ports are used. Whenever a packet is moving from a source device, the source port will be a random port. It will be from 49,152 to 65,535. It can be anything in between this number, this range. And destination port will be well-known port or reserved port. Well-known are the most commonly used services like DNS, HTTPS, FTP, SMTP. They all comes in 0 to 1023. And reserved ports are these are the ports which are purchased by the vendors. So destination port can be a well-known port also or reserved port also, but source port will be random port, which will be randomly allocated by the device source device, which is what may be the source device can provide anything for source port in between the range of 49,152 to 65,535. The commonly used protocols in transport layer are TCP, UDP, OSPF, ICMP. Okay, so let us see the network layer. In network layer, source IP and destination IP is added. So basically, a packet needs an IP address, because we cannot identify the device on based on names. So every device is identified in network on the basis of IP address only. Whenever a packet is moving to internal network to internet, it needs the IP address to find out the device. So source IP and destination IP are the most important thing to identify a device. So source IP will be added the IP address of the device which is generating the request, which is transferring the packet. Okay, and destination IP will be the IP address of a device to whom which are sending the packet. The protocols which are used in network layer are IPv4, IPv6, IPX, and ARP also. In data link layer, the source MAC address and destination MAC address are added. MAC address is the physical address. Okay, It is the MAC address is the physical address of a device, and IP address is a logical address of a device. So device, if you are contacting a device, if you are connecting a device within a network, it will we can connect a device within the network by using MAC address. So MAC address is needed to interact with a device to establish a connection or to transfer a data or to identify a machine. MAC address used within the network. So within the network, device uses MAC address only to communicate each other. Only MAC address is sufficient for the packet. So source MAC address will be the MAC address of the source machine, which is generating the packet, which is sending the packet, and destination MAC is the MAC address of machine to whom which are sending the packet. Okay. So MAC address is the address which is physical address which cannot be changed, which is provided by a vendor to a particular adapter. Either we can using a Wi-Fi or Ethernet adapter. So every adapter will have a MAC address for every adapter. Okay. And physical layer, the entire data what the physical layer get from all above layers, entire data will be converted into binaries, either 0 and 1s. The data till the data link layer, what packet data the packet will have data, the entire data will be converted to into zeros and ones, and is transmitted in form of voltage. If the cable, the device connected cable is copper cable, then the voltage. In form of frequency, if the device is using Wi-Fi connection, and in form of light if the device is connected with the optical fiber. So the more commonly used protocols are USB and Ethernet in the physical layer. So let us see the functionality of the each layer by taking an example in real time. Let us consider a user is accessing a Chrome, using a Chrome browser to access the website www.youtube.com. So whenever a user types the website URL in Chrome www.youtube.com, the interface the Chrome application is providing to access the interact with the machine, that is the application layer comes in use. Because the application layer which helps in providing interface between user and the device machine system. Okay. So Chrome application will provide an application interface between a user who is accessing the YouTube and the machine who is going to provide the website to the user. The interface the Chrome application providing, which helps in the interacting between the user and the machine system. Okay. So that's the purpose of application layer, which provides only interface. Okay. Let us see when we enter the www.youtube.com in Chrome application, Chrome browser. The operating system, when we enter the any website name in the Chrome application, it will see the we entered as a text. So the operating system Chrome application will not understand any that the human readable language, so it will translate that data to the machine readable language. And as we can see, only we entered the website name, so he cannot find the website on just basis of the name. So he tells the operating system that he needs an IP address to display that website. So operating system will generate a DNS packet. Okay. After this presentation layer and session layer helps in the establishing session. So DNS packet will be produced when we enter the whenever we access any website, the first packet will be generated as will be DNS packet, because first it needs an IP address to contact a website. To contact a website or reach a website, we need a IP address. So the first packet generated from device will be DNS. Whenever we type www.youtube.com or any other URLs, the first packet will be DNS packet. So when DNS packet is generated by the operating system in transport layer, the headers will be added to that packet. to the data, the headers will be added. The header, in that header, in transport layer, the headers will be, the source port will be any random number in between 49,1952 to 65,535, and destination port will be 53. It will be 0 to 1023. It comes in between 0 to 1023 in well-known range. It will be 53 because, as we all know, the DNS service used port number 53. So destination port will be 53, and then it moves to network layer, where it gets added with the source IP address. Source IP address will be the machine's IP address, the user who is accessing the Chrome application to view the website. So that will be the IP address of the machine, which is provided by the ISP service provider. Okay, and destination IP address will be the DNS server IP address, which is also provided by the ISP service provider. Okay, and then in data link layer, source MAC address of the machine will be added, and then destination MAC address of the DNS server will be added. If the destination MAC address is not maintained in the ARP table, in that case the ARP packet will be produced. So let us take an example that already ARP table is resolved, and MAC address is already present in the ARP table. So MAC address, destination MAC address is added in the data link layer, and the entire data with the DNS query will be translated into the zeros and ones by using in physical layer, by using protocols like USB, Ethernet, and the data will be translated as light, because in most cases we use the optical fiber. So this is how in real life the OSI or TCP IP model works.